Hi everyone, I am Dr. A. Muralesan from Biomedical Engineering Department in KSR College of Engineering. In this video, we discuss about signal flow graph in control system. So, for mainly to solve the signal flow graph, you need the Mason's gain formula. So, Mason's gain formula is used to find the overall transfer function. That means Laplace transform of output divided by Laplace transform of input. That is C of S divided by R of S equal to summation of Pk del k divided by delta. Here Pk is the path gain of individual forward path. Then delta is the determinant of the overall signal flow graph. So here delta is the given by the formula delta equal to 1 minus sum of loop gains by the all individual loops plus sum of gain products of all combination of two non-touching loops and minus summation of products of all non-touching of three non-touching loops. Then plus it will be goes on like that. Three non-touching, four non-touching, alternatively plus and minus. Here the delta k is uh, the path non-touching path in the kth forward path. Suppose it have a two forward path, and del 1 will be the part which is not touch in the first forward path, that is called del k. So, for example, we are taking the signal program. Here we have RFS and CFS. RFS will be the input side and CFS will be the output side. You have to find the forward path. Forward path will be the a unidirection path from input to output. So in this example, the first forward path will be traveled from 1, 2, 3, 4, 5, 6, 7 and 8. So that will be the first forward path in this example. So if the gain will be the 1 into G1, G2, G3, G4, G5 into 1. So that will be the first forward path gain, that is called P1. So 1 into G1, G2, G3, G4, G5 into 1, which is equal to G1, G2, G3, G4, G5. So now you have to find the second forward path. Here it will be follows 1 to 2, from 2 to it routed to 5 through G6, then again 5 to 6, 6 to 7, then 7 to 8. That will be the second forward path. So second forward path will be the 1 from 2 to 5, 5 to 6, then 6 to 7 and 8. So now the second forward path gain, how it will comes? P2 equal to 1 into G6 into G4 G5 into 1, that is P2 equal to G6 G4 and G5. So we have two forward paths in this signal flow graph. Now we have to find the individual loops. Loop is nothing but a starting point will and ending points are same. For example, here the point 3 will be started, it goes to 4, then again it will comes to point third point through minus h1. So this will be belongs to a loop. Similarly, in the second loop will be it will be start from third to fourth and then fourth to fifth. Again it will be fifth to third point through minus h2. That will be our second loop. Then third loop will be the 6 to 7 and again it goes to 7 to 6 through the minus h2. So, 3. So it have a 3 individual loops. So first loop. So loop gain will be called as G2 into minus h1. So that will become minus G2 into h1. Similarly, the second loop I already said G1, G3 and minus h2. The third loop will be the G5 and minus h3. So P31 equal to minus G5 into h3. So we have a 3 individual loop gains. Now we have to find which two loops are non-touching. In this case, the loop 1 and 3 is a non-touching. Again, the loop, second loop and third loop is also non-touching. So we have a two pair of non-touching loops. You have to find the two non-touching loops. So first pair will be the P12. You have to combine the two loops. So P12, so minus G2H1 minus G5 and H3. So minus and minus become plus. It becomes G2H1 G5 H3. So second non-touching pair will be the second loop and third loop. So it will be combination of second loop and third loop. It becomes P22 equal to G2 G3 H2 and G5 and H3. So next you have to find the delta 1. That means non-touching in the first forward. Here the first forward path, all the loops are touching. There will be no non-touching parts in the first forward path. So it will be 1 minus 0. In second forward path, what will happen? It will be travel 1, 2, 5 and 6. So the first loop is non-touch with the second forward path. So it becomes del 2 minus second loop forward gain will be the G2 into minus H1, which is non-touching with the second forward path. So the second forward delta 2 become 1 plus G2 into H1. So now we find del 1 and del 2. We are finding del 1 and del 2 because we have only two forward paths. Now we have to find the delta value. We know the formula 1 minus sum of individual loop gain. So we have a 3 individual loops. We have to all sum the all 3 individual loops plus sum of gain of all possible of 2 non-touching loops. Here we have two possible two non-touching loops. You have to add together. You have to find the finally delta value. Now we know the Mason's gain formula. CFS divided by R of S equal to summation K Pk del K divided by delta. Here K will be the number of forward paths. Here we have two forward paths. So the formula become P1 del 1 plus P2 del 2 and delta. So we are nearly substituting all the values. We find P1 del 1, P2 del 2 and delta value. So you have to find all the you substitute all the values, you can find the overall gain, that is the transfer function for the given signal flow graph. Thank you.